Hello everybody, I'm Nick, and in this video I'm going to get you started with event sourcing in software engineering. And this is not a .NET specific tutorial, even though I'm a .NET channel and I will be showing things using .NET and C#. It doesn't matter what your background is. What I'm going to do here is break down the topic in so simple terms and such simple code that even if you're doing Java or Python or JavaScript or anything, you'll be able to take this video and adapt it to your own language. Event sourcing, when being taught, tends to be presented in a very complicated way, when at its core, it's a very simple topic. But I think because it's a lot of fancy terminology, people tend to get confused by it. So in this video, I'm going to ditch all that and I'm going to just explain it in plain English and just build on top of basically nothing. And you will understand when the terminology comes in once you learn the concept. Now, this video is sponsored by AWS. And if you want to find out how you can get $25 worth of free credits on AWS, check the description down below. If you liked our content and you want to see more, make sure you subscribe for more training. Check out my courses on dometrain.com. Okay, so let me see what I have here. And as you can see, all I have is a console application with 0 dependencies and literally nothing. That's why I said you can actually take this and adapt it to any language. We won't complicate things. The topic is fairly easy to understand if you bring the terminology in later. And the main idea around event sourcing is that state in our application is not just a row in a database, but every time something happens, I store that action, I store that thing, I store that event in the database in an append-only fashion. I never go and say update this thing that happened in the past, because that thing happened in the past and in a given moment in time, it was true. So what I'll be doing is, if I want to reverse that in the future, then I'll go back and have a reversal event. But that thing still happened. The great way to explain this is if you pull up your phone and you go in your bank account and you see that you have $10, then those $10 are not just $10. It was 0 when you opened the bank account. Someone sent you 100. So at the time it was 100. Then you paid for, I don't know, something that cost $50. So your bank account was 50. And then 10 was added, so 60. Then 50 was removed and you're back at 10. So these are all events in a given moment in time where you got money or you spent money. And a great example of reversing things is, what if someone gives you a refund for a product? Well, if you pay $50 and you have a take out $50, then eventually that refund will replenish those $50. And to get the final number, all you have to do is say, okay, what are all my transactions in my bank account? Oh, I have these 10 transactions. Let's go ahead and add on remove all that money from whatever it was in the beginning of the balance, let's say 0. Now, if that sounds inefficient to do every single time in a real application, there are ways around it. But the fundamental concept is that things happen and you build state out of the things that happened. So let's go straight into the code, because there's no better way to explain this than actually showing you code. So I'm going to go ahead and create an in-memory database to store my events. And I'm going to call that student database. And I'm going to use DomeTrain, my platform, as an example here. So let's say a user is created, so a student is created, then they can update their profile, maybe they can enroll into a course, or maybe they can unenroll from the course, or I can unenroll them. And to store those events, what I'm going to do is I'm going to create a new directory and call that events. And I'm going to create a very simple class here, an abstract class called event. And what this class will have is 2 things. First, events are things that happen in a given moment in time. So I need a way to store a timestamp. So I'm going to say date time, and I can say created at, the normal terminology is timestamp. I'm going to use created at UTC here. And then I need a way to correlate a bunch of events, because let's say that something happened for Nick and Nick has ID 1 in the system, and then you have John and John has ID 2. We still need a way to identify those 2 users. Things can happen within those users, but I still have ID 1 and John still has ID 2. My stuff, my events and John's events will be distinguished by separate streams of events. Imagine it as a sequence of events about a given thing in your system, in this case, the student. Well, streams can be identified by stream IDs. So all of my events will have a stream ID here. So stream ID, here we go. In this case, I'm going to use a GUID to represent my stream ID. That really depends on what you're doing. Some systems use a string, it can vary, but in this case, I'm gonna use a stream ID, and I'm gonna remove the setter from here. I'm gonna turn that into an abstract GUID. So here I have my base event. Now, I want to represent first what happens when a user is created, a student is created. So I'm going to create a class called student created. Note that I don't have a student class. This is very important. So here I'm going to create my model. What would a student created have? Well, a student ID, of course, and you can argue this should be ID, but because events are a separate sort of thing, there's not so much ambiguity in terms of what each thing represents, so I'm still gonna keep it as student ID here, then full name, email, and date of birth. Now this will be extending the event class that I just created, and I'm going to implement the missing member, which is a stream ID. So the stream ID in my case will be mapped to the unique identifier of the thing I want to represent. So in my case, it is going to be the student ID. And I'm gonna do that, and that's that. There's nothing else to touch. I just say that the stream ID for my student is the student ID. Then all I need to do is add all the other actions. So what would I have? I would have student updated. So again, this would extend the event. And what would I have here? I would have a student ID, and I can only update the full name and the email. You can't really change your date of birth, so you shouldn't be able to update it. Then I'm going to have the student enrolled. So that would look something like this, where I have the student ID and then the course name. The course name could be a course object itself. I want to simplify this. So I'm only going to have the course name. So when you enroll to a course, all we do is we store the name of the course. And then I'm going to have the unenroll, where someone can say, oh, I want to unenroll from this course, maybe to get another one, and so on. So now I have all of my individual events. So now I'm going to go to my program.cs and create a student database instance. So new student database. And I want to go ahead and create a student. How would that look? What you would say is that a student has been created. So I would have a student created object using the student created object I just had. Now, to have some persistence with the IDs I'm going to be using, I'm going to hard code a GUID here for the student. So I'm going to say student ID is that, and then I'm going to pass all the other properties. So email, full name, and date of birth, and that's it. And that represents now that the student was created. And then in my database, all I'm going to say is student database dot append. So I'm going to append an event in my database that the student was created. Obviously, the append method does not exist. So I'm going to go ahead and create it, but it's not going to be a student created. It's going to be an event. So any event will call that append method to be saved in a database. Now, of course, I need to store these things in memory. So I'm going to say private read only, and I'm going to store it using a dictionary where the key is a GUID, where the GUID is a student ID. And then I'm going to use a sorted list, even though it's not necessarily mandatory for this example, but I want to signify a thing that's very important here. And that is the ordering of the events. And I have intentionally omitted, if you're very familiar with event sourcing, things like version from the event. Maybe there's something to explain in a different video. But the key here is the date time when the event happened. And then I'm going to have the event itself. And I'm going to say student events equals new. And that's that. So what this sorted list is supposed to represent is that stream per event, in this case, the student events. So what I'm going to say is var stream equals, and I'm going to try to get that stream for that student. So I'm going to say event dot stream ID, and if you don't find it, return null. So if the stream is null, then take the student events with this stream ID and create a new entry. So equals new sorted list of this type, and that's it. And now I've created the stream for that student ID, and I can start adding things into the stream. All I need to say is I want to take that and say add, and I'm going to store the event.created at, but I'm going to have to set that date as well to datetime UTC now. So I'm going to store that here, and then I'm going to store the event itself. Here we go. And that's it. all I'm doing is I'm storing it in a sequence, in a stream. I'm saying add this at the bottom of this sorted list based on the date it was added. So now if I go back to my program.cs, that's it. That's as if I saved something in the database. Now, what if something else happens? For example, what if I also want to store that the user was enrolled? Well, I would have something like this, where I have that student ID and I say enroll the student in the course from 0 to Hero REST APIs in .NET, and then append that. And what if the student decides to change their email? Well, very easy. All I'm going to say is student updated, and I'm going to pass nickchapsas@dometrain.com and then the full name and the student ID, and then click append. And that's it. And if I just quickly run this to show you what's happening behind the scenes, if I just stick a breakpoint here maybe, and I say debugged, let's take a look at what's happening. In fact, let's go through every single step. So first, I'm going to go ahead. I don't want you to go away. I'm going to go ahead and just step over this and step into the append method. So we're going to try to get the stream. The stream is null because there's nothing about the student. Then I'm going to create it. I'm going to set that date and then store that event. And then if I go to the next thing, you can see in here now that in the count, I have one stream that has one event in it. And I can keep going. This time we have this stream and I'm saying just add it at the bottom because this happened later and this happened later. So if I go in my database over here and I click stored events and I expand that, there's a stream for this student and it shows what happened in sequence. Student was created, then they enrolled in a course, and then they were updated. I have everything about this student. Now this stream contains everything about my student. And if I need to know what happened with that student, I also have a home of auditing by default. But what happens if I want to represent my student in some way? Well, there's a way to do that as well. So I'm going to go here and create a student class. So I will have a student class, but it's a bit different than what you might expect. That student class will have all the usual suspects. So we have an ID, we have a full name, we have an email, enrolled courses, and then date of birth. We have the properties as you would normally have. But then we're going to have a few methods, because what we want to say is that the state of this class should only change through these apply methods. Now I know I have these as setters, so they're not really immutable. There's a reason for that, which comes into the picture later. So for now, I'm going to leave it as it is. And what I'm going to say is I'm going to have an apply method per event that can mutate this student class. So I'm going to say student created, for example. I'm going to say student created. And then in the apply method, I'll say, okay, what is this event changing about my student? Well, I'm going to have the ID set. I'm going to have the full name, which is also a part of that event. So student created dot full name. I'm going to have the email as well. So email is set. And I'm also going to have the date of birth, right? So all of those things are set by the created. Then I have updated, which sets, again, the ID, which I could skip, but I'm not going to do that. So the ID, the full name, and then the email, because those are the two things we can change. Yeah, we can skip that because we won't really be updating the ID. So we can remove that. And we do expect to have a student created before updated ever comes into picture. So there's that. And then we also going to have apply methods for enrolled and unenrolled. And you might be able to see where this is going, because those are all private and they should be private. And there should be only one public apply method in our scenario anyway, which says that I'm going to accept that event and then I'm going to map it to the right method. I'm going to use a switch here. There's other techniques and there's other approaches. Some people call this evolve. Some people call this process. I'm just going to call it apply. And all we're going to say is take that event, determine the type of this event using a switch, and then call the apply method appropriate for that type. And now you should be able to see exactly where this is going, because now I can say that my student, if I want to represent my student, is a student database.get student, which doesn't exist, but I can still pass the student ID in here. And I'm going to go ahead and actually use the student object over here so the right method can be created. So public student, get student ID. And I'm going to go ahead and show you how easy it is now. Now, first and foremost, if the student events does not contain key student ID, then return null because we don't have a student to return. But if we do have something, then create the bare bones of that student object and then get the student events using that student ID. So now we have the events and we're going to say for each student event in student events, go ahead and call the student.apply method per event. And because that is a sorted list, I'm going to have to call value and in the end return the student. So now I'm going to build the state that represents my student on the fly based on those events. So let's go ahead. I'm going to turn this into var and let's go ahead and see this again step by step. So I'll go ahead and step over the database and create my student. So created, then enrolled, then updated, and then I'll say get my student back. So I'm going to step in here. Does the thing contain it? Yes, it does. So I'm going to say new student, get the events. I have 3 of them. They are sorted by the date, the time that they happened. So I'm going to go here and go ahead and apply every single one of those events, setting the state of that object every step of the way. And then in the end, what I get is a materialized view that represents that student. So there's a few things now that come into picture when it comes to terminology. So I have a stream containing all the student related things. So I have a stream per aggregate to represent that student. And then the student in this case is also the aggregate root. We don't really need to explain that complicated terminology that much. You understand the functional aspect of things, and that's really what matters. So I have the ability to append only what happens to that student and then build the materialized view to represent that student based on what happened. Now, there's a few things that you might immediately think of. And the first thing that I would think in this situation is that, isn't it a bit costly to just go ahead and pull all the events from a stream for this specific aggregate for the student and build it every single time? Wouldn't it be easier to just sort of keep the state or a snapshot or a materialized view of that thing in the database or maybe in our system and then just return that? And the answer is yes, and that's what's called a projection. So let me show you. I'm going to go ahead in the append method and I'm going to show you how we can build what's called a synchronous projection. And it's going to be synchronous because we're going to be updating that state as we append new events. We're still going to append events, but we're also going to update that state. Now, whether we're going to do it synchronously or asynchronously depends on the scenario you are into. If you're in a read-heavy scenario or if you're in a write-heavy scenario, and also if you can deal with some eventual consistency or if you absolutely need strong consistency. I don't want to go too in-depth into those concepts because I do have a video coming for that as well. I want to keep it simpler. So let's go ahead and see how we can build a simple projection. What I'm going to do is I'm going to create a separate dictionary here. I'm going to say private read-only dictionary GUID and then student. And that will have my students in here. And then every time an event comes in, what I'm going to say after I store that event is go ahead and the students dictionary, use the stream ID, which I know is a student ID here, and set my student state. Now to do that, I'm going to use the get student method and I'm going to pass down the event.streamID. And that is definitely not null at this point because I have at least one event that I just added. And then if I want to get that view, what I can say is public student get student view, and then I'm going to just return that student. So I'm going to say students.get value or default. I'm going to try to get it based on the key, otherwise return null, and that's that. This is definitely not null at this point. So I'll go here and I'm going to say student and then student from view, and I'm going to say get student view, and I'm going to stick a breakpoint and quickly show you what's happening. So I'm going to still append everything every step of the way, but I'm not writing one thing, I'm writing two things every time. So I built first this state by just going through every single event, but I also, if I step in here, I can go into the students thing that contains all of my materialized views, and I can see that I also have stored that, and I don't need to go and get everything now and then rebuild it. I can just go ahead and return it from that storage. So that's all really, really nice. And fundamentally, that covers a big portion of what event sourcing is. Now, the alternative to all that is, of course, not doing this synchronously, because remember, if you're in a real database scenario, you would have to wrap this into a transaction, because the addition to the database of that event and the update of your current state should happen at the exact same time, and they should succeed together or fail together. So it should be atomic. Now, what I want to do to just give you a better understanding of everything is bring a real database into the mix. And for that, I'm going to use DynamoDB. I've built event sourcing systems in DynamoDB in the past, and DynamoDB and also things like Cosmos DB as well, they are great for that sort of thing because of the partitioning strategy. And DynamoDB, especially because the terminology, I think, and all the features that it has makes this such an easy experience. And if I was to build an event sourcing system, I would use something like DynamoDB. I know there's libraries like Martin that use Postgres to do that. I'm more of a DynamoDB person, and that's why I'm going to use that here. So what I'm going to do is I'm just going to quickly close all the tabs, and I'm going to add DynamoDB into the mix, the V2 library, and that is it. And I'm going to keep it very, very simple. I'm not going to complicate it at all. I'm going to go to the student database, and I'm going to remove these in-memory representations, and I'm going to replace it with a private read-only Amazon DynamoDB, and I'm going to say DynamoDB here equals a new client, and that client will have a region of EU West 2 because that's where I am. And I'm also going to say private const string table name, and the table name is students for this case. Now I'm just going to quickly show you how easy it is to create a table in DynamoDB. So I'm just going to say create table. I'm going to say students here, and then I'm going to set the partition key and the sort key. Event sourcing and NoSQL databases play very nicely together, especially because of the partition key. So partition key is not necessarily like a primary key in a database, because the uniqueness of an item in databases like DynamoDB is the combination of the partition key and then the secondary key, in this case, the sort key, which, as you can understand by the name, it is also sorted by default based on the value. So what we're going to do here is create a partition key, and we're going to call that PK, and that's for a reason I will explain later. And then I'm going to call the sort key SK, and that's it. And I'm not going to customize anything else. All I'm going to say is create that table, and that's it. We're going to give it a second, but we're not really going to touch it until we push some data into it. And then I'm going to start updating this code to use DynamoDB. So let's go ahead and just delete everything from here, but still implement the exact same logic. So in append, I just want to write a thing in the database, and that's it. Now, because we're going to be writing a lot in JSON and how serialization works and inheritance works with things like inheritance and generics in C#, we're going to have to change the append method a bit. So I'm going to turn this into a generic T-type parameter, and I'm going to say where T is event. And I'm also going to change this to an async task because we're going to be awaiting things. So this is now append async. And I'm going to do the same for all the other methods, but for now, I'm just going to delete them. Now, because I'm using inheritance in my events, I do have to change this event class a bit to let it know that it is inherited by some other classes. So the serializer and deserializer of JSON knows how to give me the right type back when I say serialize this event back into a student event. To do that, first, we have to say that this is using JSON polymorphism. And then I'm going to have to add a JSON attribute per type I'm storing. And I'm going to have to also specify the name of that event. So when an event is stored and then it's retrieved, the right type is used to serialize it and deserialize it. That would look like this. And again, if you want to grab any of this code, it's in the description down below. Now, since I'm going to be using a partition key and a sort key for everything I'm storing, I'm going to need two properties in my class. So first, I'm going to say JSON property name. I'm going to say PK, and I'm going to create a property which is a string because that's what I created in DynamoDB, and it's going to be called PK. Now the PK is getter only, and it's actually computed based on the stream ID. So the string version of the stream ID will be my primary key. And like I said, the uniqueness is the combination of the primary key and the sort key, which, if you want to get very, very technical, datetime might not be the exact thing you should be using as a sort key. You might want to use a long timestamp, but I don't want to go too in depth in this. The idea is that you could have clashes if for some reason you have two events with the exact same created at in the same stream. It's an edge case, but I didn't want to mention it. And then the sort key over here is going to be sk and sk, and it's going to be the created at using the ISO format, which is also string sortable. Why is that important? Because everything in that stream now in DynamoDB will be stored by order. And then all I need to do in the student database is just say, write this event. So first I'm going to set the created at UTC as UTC now. Then there's a bit of code to serialize everything down to attribute, which is what DynamoDB expects. And then I'm going to create a create item request, which is a new put item request. What we need to pass down is the table name as the table name, and then we need to pass down the item as attributes, which we already have, and that's it. Then in the end, Amazon DynamoDB and put item async, create item request, and just await it. And that's that. So let's go back here and update everything. Append async, await it, and over here, await it again. I'm not going to check the students first. What I'm going to do is just run this code and show you how easy it is to just store everything in that table now. So we're going to create the database instance. We're going to go ahead and say append, and then I'm going to set the values, turn everything into attributes, put item request, and then call the put item async. And I'm going to do that for everything. And as you can see, everything run. And now if I go back to DynamoDB and I click students and I say explore table, we're going to see 3 items and they all store the type name of that event. So student created over here, all the details about that event. And I can go back and see all the individual things in order using that sort key. So student enrolled, and then later, as you can see, student updated. So now it's a matter of retrieving it from the database and building that view. And this idea of doing it on the fly sometimes is called a live projection, where you don't really store it or synchronously or asynchronously, you just calculate it on the fly. So first let's go here and say, create the method for get student async. So we get the student by student ID. Now DynamoDB is a bit weird when it comes to querying, but that's what a query would look like. So we say we have a key condition, the primary key. We pass down the primary key value like this. S represents a string and our key is a string. So we do that. Then we're going to fire that request to get a response. So we're going to say Amazon DynamoDB query async, and we're going to say if response dot items or dot count actually is 0, then we're just gonna return null. This means there is no events for the student, so there's no student basically. Then we're going to convert the attributes, which is the item as attributes, as documents using the from attribute map. And then we're going to have to convert the documents into the objects by going through a JSON mid state first. That would look something like this, where student events are the documents, select JSON serializer, and then deserialize that as an event. But now for this to work, I actually have to change one thing. I'm going to have to pass down some JSON settings because that type attribute needs to be taken into account. And I'm not dealing with the order. This is a bit of an edge case, but I'm going to add it anyway. So all I'm saying is these are my JSON serializer options, and I'm going to pass them down over here when I say deserialize this object. And then in the end, I'm going to do the exact same thing. So var student equals new student. And then I'm going to loop around everything, and everything should be ordered by default already because I have that sort key. If you don't trust it for some reason, you can still have something like order by, and you can say x dot created at UTC. So you'd have that, and then you would say apply that student event, and then return the student that is not null, and that's it. So let's go ahead and actually update this program. And in fact, I'm going to delete all the students first. So let's go here and say just delete all the items, and let's go through the flow again. So breakpoint the top, and let's go and not only create the student and retrieve it. Of course, I need some code to actually retrieve it. So await async, we have that. Let's do it. So let's go through everything. We're going to store all the items. As you can see, we're storing them 1, 2, 3, here we go. And then in the end, let's go in here, get the request, get the response. We actually have a count of 3 because 3 were the items that we stored, 3 individual events. We go back, we get the student events, and then we loop around them. We apply them, and as you can see, created first, then we have enrolled, and then we have updated. And in the end, I'm getting my student as an on-the-fly materialized view, and that's it. And that's really cool, but what's even cooler is that DynamoDB actually supports transactions, meaning we can actually store that projection, that materialized view, as we're saving the new events, and they can fail together and succeed together. So in here, instead of having this put item request like this, I can do the following. I can say var transaction request equals new write transact write items, or items request, and then I'm going to have transaction items. I'm going to create that list, and then first I'm going to write the event itself. So that is a put. So put equals new put, which contains the table name, and you can have cross-table transactions as well in DynamoDB. So if you stored your projections and your events in separate tables, they could still be part of a transaction. And I'm going to say that the item is the item as attributes. And then I'm also going to have the new write item, and that would be still a put on the same table, but the items I'm going to store is just the student, the materialized view. So to calculate that, what I'm going to do is I'm going to go up here and I'm going to say var student view equals, and I'm going to read to get the current state of the student. Now you can see where there could be performance issues with this approach too, but I'm reading from the projection. And in many cases, if you need that synchronous, strong consistency, this is what you're going to have to deal with. I'm going to say await get student async, and don't worry, we're going to update that get student async method to use the projection instead. So I'm going to say event dot stream ID, otherwise return a new student. And this is only relevant when we have the first event only, but it's still good to have. And then we're going to say student view dot apply, and we're going to apply that incoming event. So apply that event, and then serialize everything into Dynamo's format. So that can be done like this to turn everything into an attribute map. And then in the end, I'm just passing it down here, and I'm saying await DynamoDB transact write items async, and pass that request. And now if I go ahead and I just clear the database again, let's refresh and just delete everything. Here we go, bye-bye. And then update get student async to read from that projection. So I'm going to say, just comment this one out in case anyone wants to grab the code and get the previous version. The signature will be the same, but the code in it will be different. Now, the way I'm going to write this is a bit interesting. So what I'm going to do is I'm going to say that I have the get item request. So we're not listing anymore. We're not querying. We're just getting a point read for a single item, which is very, very efficient. And then I'm passing partition key and a sort key because that's what uniqueness is. And the sort key and the partition key is student ID, and then this underscore view, or you can say projection, or you can say state or current. It's completely up to you what you want to say. I don't want to confuse you with terminology. I just want to show you how you can do it conceptually. So now that means that I can do a very efficient point read, get that response using the get item async method, and then if there is nothing, then just return null. Otherwise, do this conversion dance and return everything back as a student. And that's it. Now, as you can understand here, this means that I have to also add in the student's object that partition key and sort key logic, because this will also now need to be stored in DynamoDB. Same thing as before. The only difference is that I have to add this view suffix to prevent it from being in the same stream as everything else, to make it even more efficient. So you don't have to read and ignore a file. And once I have that in place, again, my database is clear. So I'm going to say, go ahead and just run it, step over everything. And I'm going to say, create and append that first event. And I'm going to go to DynamoDB at this point. So if I refresh that, you see two items here. One of them is the view. The other one is the event. So the first event, student created. And then the second thing is the view that shows me the current state of that student. So date of birth, email, enrolled courses, and so on. Then if I go and I say step over the enrolled event, what's going to happen is I have now three items, the view and the new enrolled event. So that exists, but also my view was updated and I have that enrolled courses over here. And then I can keep going and eventually read that item. And you can see I have everything, but this is now coming from DynamoDB, from that projection, from that view, that state. And that's how you can do it synchronously with a synchronous projection. But you can also have an asynchronous projection, and DynamoDB is excellent for that because it has a CDC mechanism or a change data capture mechanism built in. And the idea is that every time you change something in the database, in the table, you can get a notification, an event that contains that information. You take that and then you do anything you want with it. So if you didn't have this transaction, what you could have is you can have a new Lambda over here. I'm going to go at the bottom and say that I want a new simple DynamoDB function. And I'm going to say event sourcing tutorial.lambda. And what this Lambda can do is every time a document is updated in that table, then I get a notification and this function handler method is triggered and I have the records that were updated or changed or deleted or whatever. So what I would do is I would say record dot, and I would get the DynamoDB stream record, and then I can get both the old image and the new image. I'm going to get the new image over here, and I can say to JSON, in fact, I can go ahead and update this client and these events to be able to do that. Here we go. And I should be able to say to JSON and then convert that into whatever I want and then update my projection using that asynchronous flow. And that's how you'd have an asynchronous projection to create that state. And that's it. Fundamentally, that is the concept. You just keep appending events of things that happened and then you can create that state. And the great thing with this is if your use case changes in the future and you need a different way to represent that data, then you can just recalculate that projection based on the new requirements. There's no data lost. You can always go back in time and see exactly what happened. And it's a very, very nice way to build software. I hope this was easy to understand. Please leave a comment down below if you want to learn more about this topic, because these are things I've done quite extensively in the past, but I just tend to not talk about it because I don't know how interesting it would be for everyone. But if you think that's interesting to you, leave a comment down below, let me know, and I'll make more. But I want to know from you, what do you think about all this? And is event sourcing now easier to understand? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.